Hi there, this is Penelope, and this is a short video in a series of short videos covering review of basic arithmetic skills. And in this one, we're going to look at prime numbers, what they are and why we need to know about them. If a natural number has only two factors, which are itself and 1, it's called a prime number. So the first 6 prime numbers are 2, 3, 5, 7, 11, 13, and so on. So 2 can only be written as 2 times 1. 7 can only be written as 7 times 1. 13 can only be written as 13 times 1. Now the big thing about prime numbers is that every natural number can be written as the product of prime numbers. For example, 126 has a whole list of factors. Let's write them out. Of which 2, 3, and 7 are prime numbers. So we can actually write 126 as being equal to 2 times 3 times 3 times 7. Now, you can do this on your calculator, or you can do it like this. What we do is we successively divide the number by increasing prime. So let's start off with 126. And let's divide it by the smallest prime number, which is 2, and we get 63. Clearly 2 won't go into that now, so we need to try the next prime number, which is 3, and that will go in 21 times. Let's try dividing that by 3 again, and we get 7. Clearly 3 won't go into that, so we'll divide it by 7 this time, and we're down to 1. So 2 times 3 times 3 times 7 must equal 126. But you can do that on your calculator. It's quite quick. Let's have a look at some other examples. Let's have a look at 84. Okay, so let's set it up. 84, divide by the smallest prime, and we get 42. We can still divide that by 2, and we get 21. Can't divide that by 2 now, so you have to try 3. Yes, we can divide that by 3, and we get 7. Now we can divide that by 7, and we're down to 1. So 84 is equal to 2 times 2 times 3 times 7. And a bigger number, 512. So set it up. Divide it by 2, we get 256. We can divide that by 2, we get 128. We can divide that by 2, and we get 64. Take that a bit more. Divide that by 2, and we get 32. Divide that by 2, and we get 16. Divide that by 2, and we get 8. Divide that by 2, and we get 4. Divide that by 2, and we get 2. Divide that by 2, and we're done. So now we can say that 5112 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 times itself 9 times, which we'll write as 2 to the power of 9. So why do we need prime numbers? Prime numbers are important in finding the LCM and the HCF, the lowest common multiple, and the HCF, the highest common factor of a set of numbers. Now those are covered in a separate short video, but primary numbers are the building blocks of whole numbers. Now most modern computer cryptography works by using the prime factors of very large numbers. So the large number that was used to encrypt a file can be publicly known and available because the encryption works, so only the prime factors of that large number can be used to decrypt it again. Though finding those factors is technically only a matter of time, it's actually a matter of how much time. And sometimes we say, well, it's so much time that we say it can't be done. It could if we had the computer power. So it is possible that some new mathematical strategy or some new hardware could lead to quicker prime factorization of really large numbers, which would actually effectively break down modern encryption, which would be a bit of a problem. But at the moment, your calculator will do it for smallish numbers. It'll do it for numbers that are big enough to fit in the display of your calculator.